project, we decided to do Skyfall, the newest movie in the James Bond series.
In the clip, we're going to analyze James Bond is on top of a train fighting a bad guy. Eve Moneypenny shoots him, trying to hit the bad guy, and accidentally hits James Bond in the chest, and it knocks him off the train.
Yeah, James Bond falls about 104 meters off of this bridge that he's on, and what we're trying to figure out is whether or not he hits the body of water that's below him with enough impact force to break his neck.
I say take the shot. I can't, Amelia Bond. Take the bloody shot.
This is the end. Hold your breath and count to 10. Feel the earth move and then.
Of James Bond, Einstein, he's riding along on a train when all of a sudden he gets shot and oh no!
To start off our equations, we decided to look at the bullet hitting Bond as a system, and we used this equation with the approximated values of the bullet weight at 0.15 kilograms, the bullet's velocity at 800 meters per second, Bond's weight at 78.2 kilograms, and Bond's initial velocity as 70 meters per second. And then we do all our calculations, and we find that his final velocity was 71.395 meters per second, and this will be the initial velocity in the next equation.
The velocity that we calculated previously, I will be determining the time that Bond is in free fall. So, his distance that he falls, which is 104 meters, is equal to his initial velocity of 71.398 meters per second times t, which we don't know yet, plus 1/2 times gravity times t squared. When we solve this equation for t, we get that t equals 1.3381 seconds. So, we will now be using the time to calculate his final velocity with which he hits the water, and we'll be using the equation that velocity final equals the initial velocity plus acceleration times time. So his initial velocity was 71.398 plus his acceleration of gravity times the time of 1.3343 seconds. His final velocity is 84.487 meters per second.
Hi guys, so in the last calculation we found out that Bond's final velocity was 84.487 meters per second. Now we want to find out the impact force, and to do this we're going to calculate the kinetic energy, his final kinetic energy as he's hitting the water, and then divide it by the depth of the water that he falls. So for this we take KE equals 1/2 mv squared, and to do this it'll be 1/2, we'll plug in the combined mass of Bond and the bullet, which is 78.35 kilograms. And then we times that by the calculated final velocity of 84.487 meters per second. The answer to the kinetic energy is 279,633.2329 joules. Now to find the impact force, we take the amount of kinetic energy and divide it by the change in depth, which we approximated to be about 3 meters. This equals 93,211.1 newtons. And this is what we calculated to be our impact force. On the internet, we found that it takes about 5,000 newtons to break a bone if it's just burst to a bone really quickly, which this was if he's falling on the back of his neck. So from our calculations, we're finding out that this is plenty of impact force that's going to be able to break his bones in the upper neck.